Okay, let's do the last problem, problem 6. Let's draw the net. Actually, first let me tell you that this 4 is wrong. We'll see why in just a second, but definitely cross that out. That is not correct information. The 12 and the 6 are fine. All right, so let's draw the net so that we see what we need to do in order to find the surface area of this. So we have one regular pentagon. Again, there's nothing in the problem that indicates this is regular, but if we don't know that, we can't do this problem. So I'm just going to draw this as a regular pentagon. And then again, all these rectangles around the edge fold down so that we've got one rectangle sticking off each edge of the pentagon. Again, at this point, we're doing this to just kind of give us an idea of what we need to find areas of. So if it's not that accurate, don't worry about it. We're just trying to get a picture of what we need to do. I'll draw this a little bit more, a little bit better. Okay, and then our other base, that other pentagon is going to come off of one of those sides. It doesn't matter if you do the one that I did. You could pick any of them, really. Because then this side and this side will fold up and it will end up on top of the other pentagon. And again, since it's regular, all sides and all angles are congruent, so it's not even placed on there in any special way. It'll match up no matter which one you do it on. Okay, so when we go to find the surface area, we're going to have 5 identical rectangles that we need to find the area of, and 2 identical pentagons that we need to find the area of. And I'm going to choose to do the 5 rectangles first because they're nice and easy and we're going to get them out of the way quickly. So if I draw that one side, it has a base of 12 and a height of 6. And so we'll just fill that in here. 5 times 12 times 6 plus 2 times whatever we get as the area of the pentagon. All right, let's go over to the side here and fill that in. So this is going to parallel what we did last time for the hexagon, but it's going to be a little bit trickier as we get towards the end. So each of these sides is 12, right? Not significant yet, but I'm going to do like what I did. I'm going to pick a vertex and draw a diagonal or a segment that connects each vertex to each non-adjacent vertex to this one right here. So we're going to go here and here. The other 2 vertices are adjacent. So this splits it up into 3 triangles. So we've got 3 times 180, which is 540. That tells us the sum of the interior angles of this pentagon. And then in order to find each individual one, we take that 540 and we divide by 5, the number of angles that we have in here. So we get 108 is the measure of each angle. So let me draw that again. So that tells us that this is 108 degrees, this is 108, 108, 108, 108. Okay, then just like before, I'm going to draw a little dot in the center here, and I'm going to connect it to each vertex to form 5 congruent triangles. And we're going to look at just one triangle. We're going to kind of zoom in on that. So we've got this triangle right here. If this whole angle is 108, then that means this half angle right here has to be 54. And same on this side. This one's 54. Well, if this is 54 and 54, that's 108. That means that what's left of the 180 is 72 degrees. So we know that that's 72 up there. All right, now I'm going to drop a perp from here. And what's going to happen is I'm going to form a right triangle that looks like this. This is 54 degrees, and this is half of 72, or 36 degrees. Right, do not be tempted to say, oh, first of all, let me say this is 12 right here, so this is 6, and that's 6, so we'll put 6 right here. Do not be tempted to say, oh, this has to be 12, and this has to be 6 root 3. That is only true in a 30, 60, 90. We do not have that right here. So we have these 2 angle measures, we have this side, and we're trying to find that side. All right, this is a perfect time to use our trig. All right, so think for a second, what trig function would you use? All right, hopefully you said tangent of 54 would equal x over 6. we would multiply both sides by 6, so we would get 6 tangent of 54 equals x. And when we do that, 6 times tangent of 54, I get 8.26. All right. Now, if we pause just for a second and go back to the original picture, all right, hopefully you see now why I say this cannot possibly be the 4 that they said it was. We just found this measurement and we came up with 8.26. So I'm not sure what they were thinking when they said 4, but it does not work there. That's 4. And when we get the answer, it will match what their answer key says, which really could not come from assuming that was 4. Okay, so we need to find the area of this triangle. So area is 1/2 the base times the height. Abby says hi. All right, the base is 6. And the height is that 8.26. Now, I still have that in my calculator. I'm still going to use that. I'm going to do 1/2 of 6, which is 3, and multiply it by that value that's still in my calculator, which is more accurate than 8.26. So times 3, and I get that the area of this is approximately 24.77. All right, now I'm going to double it here. And I get that the area of this is approximately 49.55. And then I'm going to multiply this by 5 to get this. So the area of this is approximately 247.75. Again, I'm not using this rounded value in my calculator. I'm using this value that's still in my calculator. So this is carrying over without doing any rounding. All right, so then I'm going to plug this in here. So my approximately 247 point, it's actually, let's go with 749. I'm learning a lot about how horrible I am at filming things, so I'm sorry that I realized just now I was writing things and it was completely off the screen. All right, so 5 times 12 times 6, 5 times 6 is 30, times 12 is 360, plus, now I'm going to double that. I get 495.50. And when I add them together, I get 855.50. It's in inches, so this is inches squared. And again, this answer comes from not rounding at all until the very end. So I just kept those values in my calculator the whole time. The exact values, not the rounded values. So this rounds to 8.26, but I use the exact value in my calculator to then find the area of this triangle, to then find the area of this triangle, to then find the area of this pentagon, to then double it to find the area of the 2 pentagons, and then I added it to 360, and then finally at the end I rounded. If you rounded at any point earlier, you're going to get a slightly different answer. In fact, it might not be slightly different. It might be 854 or 856 or something. So just realize that depending on when you start rounding, you might get a different answer. Okay, that is it. I would suggest that you go back and watch this again, just because there are a lot of steps in here, and I know that there's one like this on the test for chapter 12. So just make sure that you understand the steps, especially this part right here. Right, this part right here is where people tend to feel confused. Not necessarily drawing the net, not finding the area of the 5 rectangles, but that process of finding the area of the pentagon, and especially this finding that height that's missing. All right, thank you. Bye.